From earthquakes to floods and wildfires, disasters are becoming more destructive around the world. Rescue teams are racing to save lives. Tech is giving them new tools, from drones and robots to AI-powered warning systems. But how much difference can they really make? Let's find out. What if technology could explore a dangerous disaster zone before rescuers go in? AI-powered drones and robots can map damaged areas and assess risks in real time. But for these high-tech tools to work, they need fast and reliable data connections. Researchers at the German Rescue Robotics Center are putting them to the test. Drones could soon become a standard tool for rescue teams. They can scan disaster zones, identify high-risk areas and search for survivors. Drones are often controlled remotely and transmit live video and sensor data to rescue teams.
They have to be remote controlled. So we need a low latency, it has to be continuous, it has to be absolutely reliable, so the communication must not break, not even very, very short time. Lives might depend on it.
Wolfgang Kellerer and his colleagues are researching 6G, the next generation of mobile networks. One day it could make communication between people and intelligent machines faster and more reliable. The idea is simple. Send the machines in first. Ground robots can enter dangerous buildings. Their sensors collect information, while their thermal cameras search for people who may be trapped or injured. Drones and other AI-powered devices are already being used. They help search teams find lost hikers in difficult terrain and provide aid to people trapped by flooding. In 2023, earthquakes struck Turkey and Syria and killed nearly 60,000 people. Drones produced aerial maps of the disaster zone in real time.
What our drone operators see is happening right now. There is no time delay. You don't have to wait for the next satellite constellation to pass over an area. So what you see is what you get. And in rescue scenarios, having real-time data is absolutely crucial.
But even the smartest robot is only as good as its connection. If the signal fails, operators lose control. Researchers are testing portable mesh nodes, small wireless relays that work together. They extend wireless coverage even in difficult terrain. All of this has one goal: keeping rescuers safe. But what happens when someone is buried somewhere even those machines can't reach? Researchers are testing a very different kind of first responder: cockroaches equipped with mini sensors. These biobots can crawl through tiny gaps and hazardous areas looking for survivors. And rescue doesn't only happen on land. Underwater, strong currents and poor visibility can create new challenges. That's where underwater drones come in. This compact underwater drone is designed to make the work of rescue teams easier. According to its developer, it can be deployed in about 10 minutes and operate at a depth of up to 300 meters. And its hot swap battery technology supposedly gives it a wired operating range of about 2 kilometers for up to 4 hours.
We focus really on the most challenging conditions. So here in Switzerland, for example, we have rivers, which are quite challenging to operate in as humans.
Underwater drones are used to locate wartime munitions. About 1.6 million tons were dumped in the North and Baltic Seas during the World Wars, posing long-term environmental and safety risks. Using HD cameras and acoustic sensors or sonar, the robot can survey large areas, either autonomously or under remote control. Once it identifies an object, operators can guide it for a closer inspection and recover loads of up to 40 kilos. Using AI and sensor fusion technology, the drone combines information from cameras and sonar, allowing it to navigate even in murky water.
You have both basically visual information and acoustic information displayed as a 3D map in real time for the operator. Or, of course, if you have an autonomous interface, it's much simpler. You just say, well, we need to search that area or inspect that kind of structure, and it does it for you, basically.
The system has already been used in search and rescue missions. It could also support offshore wind, oil and gas inspections, reducing the need for dives in hazardous conditions. Drones like this take years of engineering and a lot of money. But not every AI rescue tool starts in a big company or research lab. This wildfire detection system began with an idea from a teenager who wanted to protect his community. Today, it's helping detect wildfires around the world.
I started in 2020 because I personally had family friends who lost their homes to wildfires, and I really wanted to do something about it.
Franco Rodriguez Villao was 16 when he co-founded Satellites on Fire, an AI-powered early warning system for wildfires. Today, company figures show the platform is used in more than 20 countries and helped authorities respond to more than 600 wildfires in 2025. The company also says its alert system can detect fires faster than NASA's.
We combine satellites, cameras, drones, sensors, and AI to detect fires. We have an AI algorithm that is enabling us to detect much faster by combining different kinds of information with reports from customers in territory.
The platform can send smartphone alerts to people who are in danger and notify first responders. Franco's goal is to save lives and to protect forests, wildlife and fragile ecosystems.
We want to be an integral solution for this problem globally. So this means being in prevention, detection, monitoring, and suppression of the fires.
But many regions simply don't have this technology. In many places hit hardest by climate-related disasters, rescue teams work with whatever they have. Pakistan is among the countries most vulnerable to climate change. Every monsoon, floods kill hundreds and, in the worst years, force millions from their homes. The warning systems often don't reach everyone. That's where citizen-led technology can help. Nothing but water where roads and fields once stood, Pakistan's monsoon floods are a deadly threat. In 2022 alone, flooding killed more than 1,700 people and affected 33 million others, nearly 1 in 7 Pakistanis. In some flood-prone areas, early warning systems still have gaps. Studies point to problems with monitoring, forecasting and coordination. In some places, communities, NGOs and startups are stepping in. One Karachi-based IoT company has installed sensors at 5 flood-prone sites along the Indus River in Sindh province to track water levels in real time. The system uses 2 kinds of sensors. Ultrasonic sensors measure water levels by sending sound waves and by timing their return from the water's surface. Radar sensors work similarly with radio waves and, according to the company, remain reliable even in bad weather.
तो सेंसर्स हमने इंस्टॉल करें वाटर लेवल मॉनिटरिंग के तो उस पे हमने अपना पूरा सॉल्यूशन लगाया
As the water level rises, the system sends the data to our cloud,
बेसिकली हमारे
which triggers an alert.
इंडिकेशन जारी होती है कि जो भी इरिगेशन की डिपार्टमेंट है इरिगेशन वालों के पास पूरा
Irrigation officials can then check water levels at each flood control gate on their dashboard and monitor the situation in real time.
फॉर एग्जांपल इनके गेजेस बने होते हैं प्राच पे ना
Getting that technology into rural Sindh province isn't easy. Mobile coverage can be patchy. But where they work, the sensors give authorities more time to warn people and evacuate. In Karachi, millions of people live in informal settlements that are hard hit by flooding. Many of these areas are poorly mapped, making evacuation even more difficult. A local initiative is now digitizing old maps and combining them with satellite imagery to map flood routes. People in Karachi already share flood updates on WhatsApp, warning about flooded streets and blocked roads. Now those crowdsourced reports are feeding a live map through an app called Afad Info.
We take all of that data together and we collectively turn it into a live map which lets you choose your mode of transport, and based on that it tells you what way is a safe way for you to take.
For now these tools remain local and limited. But as floods become more severe, the challenge is getting them to the people who need them most. One of the best rescue tools is also one of the simplest: phone alerts. They can save more lives than the most expensive rescue equipment. When powerful earthquakes struck Venezuela in June 2026, the country had no public early warning system. But millions of Android phones still sounded an alarm. Using data from smartphones, Google's alert system detected the quake and warned people before the strongest shaking arrived. Chile, by contrast, has a state-run warning system, one of the most established in Latin America. It sends alerts to millions of phones within seconds. At Chile's National Disaster Prevention and Response Service, every second counts. The team issues early warnings and coordinates the response to earthquakes, tsunamis and other emergencies. AI helps get those warnings out in time.
AI helps us collect, consolidate, and process information more efficiently so we can produce timely reports, issue alerts, and analyze incoming data. The goal is to ensure that both authorities and the public are warned in a timely manner.
To warn as many people as possible, Senapred relies on cell broadcast technology. Instead of sending millions of individual text messages, alerts are transmitted simultaneously from every cell tower in the danger zone to all compatible phones nearby. Even if the networks are overloaded, the warning still gets through.
Telecommunications companies have expanded network coverage across the entire territory. This allows us to reach even very remote areas with alerts and effectively cover the whole country.
Phones sold in Chile are required to be compatible with this system. When an alert arrives, it takes over the screen with a loud warning tone that's hard to ignore.
SAE has several advantages. First, the speed of communication. From the moment a message is sent to when it reaches end users, it's just a matter of minutes.
In an emergency, those extra minutes can make all the difference. So here's the takeaway. The most effective disaster technology isn't always the most advanced. It's the technology that reaches people when they need it most. Fast, reliable phone alerts are the first line of defense. AI, drones and robots are helping rescue teams go even further. That's all from me. Bye.